Alrighty, in this video we're going to review Pemdas, which is the order of operations, and we'll do some example problems where you're simplifying some kind of expression by using the rules of Pemdas and practicing using them in order to see which one comes first, etc. So Pemdas is a shortcut to remember the order of operations, and P stands for parentheses, although brackets or bracers also work. So if you have a problem that's really complex, it might have multiple sets of parentheses or even brackets or bracers. The E is for exponents. Then M and D kind of go together. So multiplication and division are on the same level of Pemdas, and you work those from left to right. And then lastly is your addition and subtraction, and those also work left to right at the same level. So there's four real levels. The P is by itself, the E is by itself, then multiplying and dividing are together, and addition and subtraction are together. And I want to mention briefly the difference between simplifying an expression versus solving an equation. So when you have simplifying an expression, you've got a whole bunch of stuff, and sometimes they'll just say simplify it, or sometimes they'll put an equal sign, but there will be nothing over here. And they'll say simplify this expression or reduce it to lowest terms or something like that. And so in that case, you're just looking at one side of the equal sign, and you're simplifying it following Pemdas. When you have something that says solve an equation, you're going to have stuff on both sides of the equal sign. So you'll have stuff on this side, and you'll have some other stuff on the other side. Okay, and they'll never say simplify an expression if you have an equation with its equal sign and things on both sides. So the way the problem looks will be different, and the directions on what to do will be different. So when you're using Pemdas, that's when you're simplifying an expression. You're only looking at one side of the equal sign at a time, and you're trying to combine or simplify that side. You're not solving for a variable by doing things on both sides. So we'll be looking mostly at simplifying expressions here. Okay, for example, simplify this expression. Notice there's an equal sign, but there's nothing over here, so I'm not solving. I'm just looking only at this one side, and I'm simplifying it. So we can follow Pemdas. Pemdas says we do our parentheses first. So we look inside these parentheses, and 2 plus 5 we can combine together and make that a 7. Now you might be tempted to divide this 7 by this 7, but because this 7 here is being squared, we have to do that part first. Okay? So we've got 3 times 7 squared, so I'll put this 3 times, well, 7 squared is 49, divided by this 7 here, and then we're multiplying by 8 over 9. Okay, so we've gotten rid of the parentheses and the exponents, so now all we have left would be multiplying and dividing, adding and subtracting. Well, there is no addition and subtraction in this problem, so all we have is multiplying and dividing, and we can do that left to right. Multiplying and dividing doesn't matter, and when all you have is multiplying and dividing, you can combine things together. For example, this 3 and this 9 can reduce to a 1 and a 3, and 49 and 7 can reduce to a 7 and a 1. So in the top I have a 1, a 7, and an 8, which is going to give me 56. And in the denominator I have a 1 and a 3, which multiplies to give me 3. So my final answer is 56 divided by 3. Okay, so we're following Pemdas, parentheses, then exponents, then multiplying and dividing, and if I had any, I would do adding and subtracting very last. Okay, let's go here. This is a lot more complex with more parentheses. So let's start with all the parentheses. These parentheses right here, I can do 6 plus 2 minus 4. So I'm going to do that adding and subtracting left to right. 6 plus 2 is 8, minus 4 is 4. Okay, now within these overall parentheses, I've got 4 times 3, multiplication, and that's divided by 12, division. So 4 times 3 is 12. So let me just write that in. 12 over 12 to the third power times, and now I have 6 over, inside these parentheses, I'm going to do this part first. The denominator is 4 plus 16, which is 20. Okay, so now here's something else I want to mention. In these parentheses, you have division. You have 6 divided by something, and you also have addition. So you might be thinking, I need to do that division first before I do this addition, because addition comes last. But because this fraction bar covers the entire denominator, it's like there's parentheses here. This is an implicit parenthesis. So this is very, 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 very important. When you have division and you have a denominator that's got multiple things in it, like thing 1 plus or minus thing 2. So multiple things added or subtracted in the denominator, there are implied parentheses Implied means they're there even though you don't draw them. Okay, so that's really, really critical that whatever's in the denominator, or in the numerator, in fact, the numerator also has implied parentheses. So when you have a fraction bar like this, everything in the top has to be combined together first, everything in the bottom has to be combined together second, because you might ask yourself, is this 6 being divided by the 4, or is it being divided by the 16, or is it being divided by both? In the way it's drawn, it's clearly being divided by both. So you first combine the 4 and the 16, even though it's addition, because there's these little parentheses here, even though we don't draw them. Alright, so let's get our final answer. 12 over 12 is 1, and 1 to the third power is 1, so this whole piece here is gone, and 6 over 20 reduces to 3 over 10. Okay, so when you're doing PEMDAS, you want to make sure you follow the order of operations, but you also want to keep in the back of your mind some kind of tricks like this where there's these parentheses or implied order of operations that's not explicitly stated.